Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. Last weekend we basically did what we wanted to do, which was pull out the renderer so that it could be more easily used by other products, but also because it's kind of a good excuse for us to clean up the renderer now that we pretty much know what it's doing, and we really hadn't had a chance to do that in a long time. What I'd like to do this weekend is continue down that path a little bit for our own benefit, not for other people's benefit, although it helps other people too, who might want to use the render subsystem. And just go through now our API and make that cleaner. And while we're doing that, I would also like to address the problem of texture arrays, because right now we don't really have a full profile of what's slow and what's not in our renderer because it hasn't been a super high priority for us. So it's premature to say what we do and don't need, but the fact that we need to do a texture change per quad because we were coming from a software rendering side of things that didn't care what size bitmaps we were using, really just doesn't play well with a lot of hardware. We could make it run fast on this particular Nvidia card that we have because Nvidia allows using texture pointers that can be set per primitive very easily. Unfortunately, that's not always a realistic way to go if you want to run on like Intel hardware. I don't know if they might still not have support for that. I'm not sure. So, as much as it might be nice to stick with arbitrarily sized bitmaps, I'm not sure how realistic that is for us in the end. And so we may want to do a way of keeping all of the sprite-based rendering going down a particular path that, say, only allows 512 by 512 bitmaps, and we pack everything into those that size. And then we can still have a path that renders arbitrarily sized bitmap for other reasons, because obviously like our debug windows stuff or the title card or things like that, those we can afford a texture change when there's only 10 textures on the screen. It's no big deal, right? So it's really a throughput issue. It's saying, look, can we get the majority, like when we have 1,000, 2,000, 3,000 sprites on the screen, which we might want in Handmade Hero, if we just make all of those run down a texture array path, then we're in a situation where we really won't have to worry about that part of the performance. You have to worry about the standard things like fill rate, whatever. On the back end, we won't have to worry about just the act of getting those quads down to the card efficiently, because right now, the dispatch overhead is going to be super annoying, right? So anyway, that's basically what we need to do. And so I'm just going to go ahead and get started on that. I am going to open up what we were working on and just bring everyone back up to speed on that. Oops. Let's go ahead and load handmade.proj and do a build. So if we go back to what we had running as of last week, if I go ahead and run this, you can kind of see that we made a simple little spinning demo here that was, hey, if you want, and this is running completely outside of Handmade Hero. So this is just a test to see, does our render engine do what we want? And where we left it was, hey, if you've got rotation in there, we actually don't currently have any calls you can make that make sprites always face the screen, right? So you see how when we rotated around, the sprites kind of rotated with it. And in Handmade Hero, we don't rotate the screen. So it's unclear that we would ever care for this ourselves. But since the renderer supports it just fine, and it's literally just the API call that isn't there, I thought we might want to address that. And similarly, we've got a couple other things we might want to address, like offsets within the system. So these trees right now are kind of floaty, right? They're floaty because we're placing the base of the sprite, but really we would probably want to place a alignment point inside the sprite. And again, that's something that we can do, and it's just an API cleanup thing because we actually have that in the Handmade Hero side of things, and so on. So just, I'd like to look at some of those things and just get a feel for that. I might also want to try slapping a lot of sprites through here to see if we can just use, because now we have this thing running as an external render test, it's pretty easy for us to profile this. We don't have the whole game to worry about. It's kind of this nice convenient thing. We can run tests on the renderer, so I can slam a ton of sprites in there if I want to, and then I can see to what extent those sprites cause us problems. When do they become problems for speed, and is that does the problem come from the dispatch overhead, or does it come from the fill rate problems? These are all things we could get out of this test app. Since we did the work to make it, it might be nice to have sort of that nicety on top of it. So let's just go ahead and start down this path. There's a number of things that I've said there, all of which I think are worth doing, so let's take a look at them. Here's our Win32 render test. This, again, is the test code that we were working with, right? So this is it here. And what I would like to do is, again, I'd like to work on the API as well as the texture side of things. So the first thing that I'd like to do is just, now that we have it working, let's talk about what, for lack of a term, let's talk about what we actually want the API to look like and what's actually bothering us in here, okay? And so the first thing I'd like to do is I'd like to break out this, so we've got this render test, right? Like we've got this Win32 render test, right? And that's an H and a CPP file. One thing I could do, and in fact I could actually break this out a little bit more specifically. What I could do, for example, is we've got this code directory here, right? We could make a directory under code specifically for the renderer and just put things in there that are the renderer. Like we could do something like that where we have that sort of basis. I don't really know if I want to do that or not. And the reason for that is we kind of share some code, right? Like we want to have like some common things that are shared in the renderer and so on. And you know, you can see those things explicitly in the Win32 render test itself, right? So this right here, these are the pieces that it uses. And if I open up rendertest.h, you can see that Handmade types is included, as well as the intrinsics, the math, and then the actual renderer pieces, right? And so one thing we could do is say, all right, let's make a common, and the common directory has, you know, it has the things in it that everyone includes. That's like sort of everyone who speaks Handmade Hero uses these things. So we can do that. And then we would move like Handmade Math and Handmade Intrinsics in there. So it's basically like these are the things that you need to use. And then Handmade Renderer, the renderer directory would have the two render things in it. And that would make it easier for people who want to pull that sort of stuff out to know what they pull out and what they don't, right? I'm just not sure how much value there is there. Probably not a whole heck of a lot. So I might just stay away from that for now and just, we know what those things are, right? We know what they are because they're listed here. So I think that's probably sufficient, right? I mean, I think that's probably all we really need there. So I think what I'll do is I'm just going to start down that, I'm just going to start down the road of kind of like cleaning up this API a little bit. And one thing I would like to do is inside render test, you can see that we've kind of got some stuff here that's it's defined that the renderer needs, and we kind of like stubbed it out, right? So what I'd like to do is say, well, I believe we had Handmade shared is like the thing that has all this stuff in it, right? And SIMD also, right? And so Handmade shared is actually the thing that has this stuff, like all of the pieces that we were using for it are kind of all in there, right? And so the problem is that pulls in a lot of stuff that maybe we don't actually want. Like we don't know that we necessarily need the memory subsystem. And maybe that's a little bit onerous for people, right? And that pulls in the platform layer and that sort of thing. So I do wonder a bit, like this, for example, like I'm kind of curious, maybe this should not be there, right? Like maybe that should not be there. Handmade memory. And if handmade memory isn't there, what happens, right? I also, let me go in here and pull this out into the types section, right? Because this is one of our core types now. So if we were to do that, like what would we actually need to put in there? And so you can see some of these things here, like we've got copy is one of the things that we don't have because that that is used in the memory system, right? Or that's defined in the memory system, I should say. And so I'm just kind of curious if I'm just again thinking out loud here. If I pull that out of the shared system and I put that into a standard location where it would actually be set, like let's say here, what do I actually need to worry about, And so moving along here, you can see like there's a couple issues that I guess I would have. But other than that, not too much, right? Because on here, I can just include it. And so we're talking about a pretty limited set of things. Pretty limited set of things here. Let me see here, temporary memory. So this, and this can also do it here like so. So in terms of keeping that out of, I guess, can I put it underneath though? I actually need to put it underneath, I think, yeah. In terms of keeping that out, I think that's not such a big deal. I'm gonna make the maximum and minimum there. I'm gonna try putting those in the intrinsics for the moment, like so. Just see where this is at. That should have... I feel like that should have taken care of it. I'm gonna have to take a look at this a little more carefully. I just want to kind of disentangle these a little bit, if that makes sense. And it looks like checksum of is, again, just something that wants copy. I think copy can just be in shared, though. That seems like something, because it's not necessarily about the memory allocator. It's hard to say. Like, it's hard to say what belongs where in this sense, right? But let's just put those in here and see what happens. There we go. So that's so in handmade memory, what we really want is shared to come before memory there, although I don't know to what extent shared ever uses anything memory related. It doesn't really look like it does. So I think basically if we just make this always before, then I think we're okay. And again, the fact that you have to do any of this is ridiculous. This is just C nonsense. It's just dumb. So anyway, yeah, so I want that like this, right? Yeah. So we're good. Yeah. So now I just want to think about what we've got here for these different files, and whether I actually want them all, and how, to what extent all this stuff is actually necessary to be broken up into multiple files or not. So we have like a handmade SIMD thing here, and the SIMD thing, as you can see, is just the stuff we did for making it easier to work with SIMD by using types instead of having to actually use like _mm_ whatever every time you want to actually do something. for those. And so that's how we broke that out. So we've got math, we've got SIMD. I don't think that actually needs to be here necessarily, because I don't think we use it there. So really, I think we only need it in Handmade, right? I think that only really I think that only really needs to be in Handmade. So, you know, if we were to put that in here, I think that basically just takes care of it, right? So I don't think the Handmade's I don't think that the stuff needs to be included in the same way like that. It can just be pulled in as necessary, I guess is all I meant. I don't know if Handmade random still needs to be here. Could also test to see if that's true. It doesn't. So actually, these might all go away. So that's even better, because now we've got less of that stuff in there. The software renderer does use some of the SIMD stuff, and probably would, like, right, because it's SIMD based. So I guess we would need SIMD for the software renderer. So where that, this right here, I guess that's the appropriate place for it. And then if we move it out, we would know, right? That they move together. So that seems pretty reasonable to me. I'm okay with that. And so now we're down to just like the intrinsics are here because we need those, and then the math library is here. I don't actually know if the math library, again, we can sort of continue to back these out a little bit. I don't know to what extent the math library is actually used in this file. I assume the intrinsics are, though. So, like, for example, if I move this down to the bottom, I'm assuming it would tell us what intrinsics we're missing. So, well, only rotate left, I guess. Interesting. So only the murmur hash update is actually the only thing that requires the intrinsics in the shared library. That's interesting. To say the least. But so math is actually not required here either. So yeah, I mean, I guess what I would say is, given that all of that is true, I'm going to go ahead and say let's get rid of those enforced includes, and let's just actually have all of these in the places that they need to be, and then we can get rid of them as we wish, right? Let's see here, so test PNG. HHA edit. And we can sort of maybe get some of those to be less, you know, we can start removing includes as we go from different parts of the system as permitted, right? And again, that's just trying to make sure we're not being overly like, we're not like pulling in too much stuff for no reason. So if I pop back over to Win32 render test now, what you can see here is we've got the OpenGL render and the basic renderer subsystem that we need. Those all make sense. If I pop back over here and look at what we're including, you can see what we're including here. I don't actually know if we want to get it any lower than that, because presumably you want like the intrinsics there. So I think that's pretty much what we want, right? And if I go through here and look at what happens as I migrate these up, I should be able to start to see where we're requiring some of these other calls. So what I'd like to do is get to the point where we're doing, you know, something more like this, just to see what's going on. Okay. So here now we can see like where some of these other things, like this memory is equal and stuff, right? So now I just want to look at where those are being done and why, and whether or not we should be including like shared in here, right? Because it may be the case that what we really should do is this. And if we do that instead of this, right, maybe that's a more sane way to do things, right? And I'm not sure. Now, string length, I'm not sure where we are defining string length currently. Seems like it should be in there, but I don't know. So it's actually in here because we needed it for the debug stuff. And I wonder if it's possible that it could be that could be put somewhere else, right? Like, could we put that, for example, into the type system here as a basic? It would be nice if it was more like in, you know, somewhere else, honestly. But it's so basic. It's like a lot of these other things. It's called from everywhere, right? Even the debug markup, which has to be included everywhere. So for some reason, we're not getting Gluent in here. That's probably just because I was over aggressive when I pulled that out. Yeah, so that's not gonna fly. So I take it back. We can't quite get that absurd, but we can get close. These can go then if we were to do that. And I think now we're basically running things pretty straightforward. So this is what you need. And again, the reason that I got rid of those interior includes was just because I want to make sure that people who look at this now know this is all they actually need, right? This is the entirety of what they're actually using. So that way we don't have to overcomplicate things. When I asked can we just use the one from Windows.h thing also, so I want to know if there's a bitmap header in Windows that looks like this so that we don't have to define it for loading a bitmap. Seems like that would be useful, but I don't know. I could just leave it in there. We'll see. All right. Let's go ahead and poke these out here as well. Like so. And so now we're kind of left with just some support functions here and then the actual scene stuff. So what I'd like to do is I'd like to pull out the actual scene stuff and the render loop here, like so. And I'd like to go ahead and make it clear like what those things are so it's really easy to see what's going on, right? So what I'm thinking here is basically like, you know, I've got this I got this function to place random elements in the scene. I've got this thing to initialize a test scene, the thing that puts the scene on, the render loop that actually like renders the scene, right? And then I've got sort of these support functions down here have like nothing to do with the API, right? They're just like Windows stuff. So what I was thinking is we could just make it so that like the one thing that it actually needs to call, which is load bitmap, we just place up here as a predefined, right? And then what I can do is just say, hey, everything below here is just support functions. So this we can make a nice big like thing here so everyone can see that this stuff is just not important, right? And we don't care about this. This is just a piece of test code. So I think all of this is fine. And I don't see any particular nonsense here. Oops. Let's just make sure that looks that way. And then I think we're good to go. This I think we did want, so I think that's not an if 0 anymore. So Win3 to allocate memory, we also need. Let me go ahead and grab that prototype out. Don't ask me why that's not marked. And let's do the same thing here. So this stuff is all like not actually part of the thing. So then we can just kind of distinguish those things pretty easily, right? That seems pretty good. That gives us a pretty nice looking sample app, right? And so now we can start to look at the sample app and see what does and doesn't look good. So this, for example, just places some random elements in the scene. Again, since it's sample code, let's make it easy for people to read and say, like, adjacent or region is clear. And what I can do is say like, okay, or you know what, we could also count, we could have it return the count, right? Count occupants in 9x9. 3x3, sorry. And so what we could do there is just say like, okay, like you pass an x and a y here, and it will return the occupant count. And so here we can just say, look, if count occupants in 3x3 equals 0, then we place it. Now we can kind of see what that does more clearly, right? So both of these are now kind of self-explanatory, so you didn't have to read that in there. That way someone coming to this code doesn't know it works, can really clearly see what we're doing. They have to understand these two for loops first, and that just gives them a little bit of help there, right? And we could expand on this a little bit by just saying, here's the center x and y. And that way these actually collapse to just x and y, which makes, again, it a little easier for them to read. So they don't have to think too much about it, if that makes sense. So now they can sort of see what that looks like, and off they go. So I guess that's fairly nice. And I guess I could say in unoccupied. I could say that, right? And off we go. Now, one of the things that we found that was a problem is when we were doing these test scene dims, what we really want to do is see how many we have. So we kind of want to say like the two of these multiplied together is like the total square count. And what we want to do is we want to fill it with like trees and walls or whatever else we have, proportional to how many of these there are. So we want like these to be related to the total square count. Like maybe like we want 1/5 of all the squares or 1/8 of all the squares or something, right? To be filled with whatever it is. Something like that, right? So what I want to do now is I want to say, let's do that with trees. Let's just say, look, like one in every, well, we know we're placing them in they need 8 free and one in the middle. So we know that like the maximum we could place would be like a ninth, right? And we don't want to be really close to that. So let's say we say 1/15 of the squares. I'm just, again, just making this up, right? So let's suppose, oh, whoops, I didn't actually quite do that right, did I? So if I just say that's how many we'll try, and that way now it won't like be dependent on that size. You can pass other sizes and it should still maybe pick a reasonable number of trees, right? So that's just like how many trees there are or whatever. And let's do another thing, since walls are not particularly interesting right now. Instead of placing the walls the way that they were placed, let's place the walls as like square things or something, right? So like, let's do this. B32, place, rectangular wall. I don't know. Min x, min y, max x, max y. And then all I'm going to do is say, check to see if all of that is empty. And we can also do a thing here where we say like, is empty. Test scene, x, y, right? And so what I could do here is say, results equals this equals grass. And again, this is not because the code is better, it's just because this is a sample app, so I'm trying to make things as clear as possible for the person who's reading it. So again, in here, what I can do is just go through and test for emptiness in all of these. So basically, I can just say, okay, for U32, x equals min x, x is less than or equal to min y, max x, sorry, plus x. Place equals true. We'll just assume that. So what I'll do here is say if, and I can also make this a part of the loop. So I can do here is say if it's empty in both places. If for some reason either of them are not empty, right, is I guess the way to say it. Either of the two x rows of wall. I'm just going to place like a rectangular wall piece. If either of them aren't empty, then we're just going to say that you can't place the wall here, right? So I want to, should also pass the scene. Like so. And so what I want to do here is say, all right, the scene, I want to know that whatever x I'm on, I want the min y and the max y of that x to be empty. Oops. Because, right, if I'm going to place like a rectangular wall area, then I want to know that it's empty in the 2 rows of x and then the 2 rows of y. So if it's not, then placed equals false. And the same would go here. So if I do my y loop now, like so, then what I can do is test min x against y and max x against y, right? So then if placed, then we actually do the exact same thing. But if you look here, this will it will like place too many things. If that makes sense. So it's like we would be overplacing one of them. So we can really do min y plus 1 and less than max y. right? Because we don't actually need to go up to the ones we already checked when we were checking x. So then we can just do the exact same loops again, like so. And actually just write them in here. Now, we could do something fancier here if we wanted to. We could do the first loop checks and the second loop places. I don't know how cheeky we want to get with that, really. It's hard to say. I mean, here's what that would look like. So if we just did it in one pass, we'd just say, I mean, in one set of loops, we just have two passes over the loop, 0 and 1, right? And so when we actually go through the loop, the first time through, we check if it's is empty. And what we would do here is just say, look, if pass equals 0, do this, else do this other thing, right? And in the case of the do this other thing, it's really just saying, look, let me set the thing here to a wall. And so this way, when we go through the first time, we do all the placement stuff, and then here we just add the placed and that. We don't really need to do it in here now, I guess, technically. You know, we can just do this. And so if we can still be placing, then we do. If not, we don't. And that'll place a little rectangular wall around so we can kind of, you know, you can kind of see what's up. Oops. Forgot we need to set both of these. There we go. And I think that should allow us to place one of these. So what I can do is place a rectangular wall here. I don't know where I want to place a rectangular wall. I'm totally just randomly making this up. So all I'm going to do here is just say, hey, let's go ahead and pick some like random set of these. I guess this will do. And you know what? I could make this be a thing. If I wanted to get a random like X and Y, right? But let's just say that walls are a maximum of, you know, 10 units wide. So, or I guess in this case I should say 9 units wide. I mean, heck, we can put whatever padding we want in there, but let's say dimx equals rand mod 8. dim_y equals rand mod 8. And then here we just do x, y, x plus dimx, y plus dim_y. And that would be the 9 wide version. And then see what we get. I have no idea what we get. But I just thought it would be nice to have like an actual structure of some kind in there, just to kind of give it a little bit of fun, right? And so now you can see that it placed like these little things in there. That maybe like that's a little too small. Like I don't know if that's really what we want. It's probably not. So I'm guessing that this actually should, this dimension thing should be like some minimum. So it's not, you know. So now we've got our test scene going. And, you know, there's a few other things here that I guess I would say maybe would be useful to try just to get more sprites in there. We can also count the number of sprites that we have, which might be nice, just so we know, or I should say how many quads we're drawing, just so we have a little bit of perspective on that. But the other thing I was going to say is we could try throwing a lot more sprites in there to see what that performance looks like. And so, yeah, like, you know, let's suppose, and I'm just going to say, let's go ahead and lemon grab here a cover file like this. And let's just grab one of these things that we can slap down a lot of, just to see how that affects our performance, among other things, right? So, like, you know, if we just make a ton of these things and place them down there, or a ton of these things, you know, what happens? Or a ton of these like little flower doodads, right? And so I'm just curious what will happen there. I'm gonna maybe grab this one because it's kind of weird looking, or maybe the grass ones are better because there's like more grass there. I don't know. So let's just grab one of these. So I'm gonna go ahead and lemon grab this guy right here. So there we go. I'm going to save that off. As test cover grass. Discard changes. And now what I should be able to do here is I should be able to really like slow us down dramatically by just putting a ton of those on there. And I think this card should be able to handle a lot. But we've got two things that could be slowing it down. One is we kind of have a crappy pixel shader right now, and other stuff. So, you know, I basically what I want to do now is like make this thing sort of roll over and die. And then once we have it dead, we can look at doing the sort of improvements that I wanted to do, right? And maybe, and like I said, maybe we'll do those, start on those tomorrow. Maybe right now I'll just go ahead and clean up some of the push API stuff that I wanted to do. And tomorrow we'll start on the acceleration stuff. But either way, like, you know, this is sort of where I want to go with it. What was this called again? Oops. Okay, so here's our cover texture, which will now be loaded in. And now whenever we're, you know, whenever we're actually drawing it, we can just push a ton of those on if we wanted to. Now, we kind of don't really have any particular pattern for it at the moment, which is a little bit of a problem, because we want to push a bunch of these onto the surface of the thing. So like if in the case where it's not a wall and not a tree, right? And we actually could do it for the tree as well. So actually that's not true. So we may want to do that as well. But if we want to here, we quickly run into one problem where the speed of the random number situation may actually cause a problem for us. So we probably don't want to call like rand mod. We could call our random potentially, and because this is pretty straightforward, right? So we could be doing that and using that to generate randoms. So we'll have to be careful here and see. We could also just use our standing random pattern, and that might be what I do. So maybe we'll do that. We'll see in a second. I don't want to promise anything. I'm not sure what we're going to do exactly. But anyway, so if we got this ground P here, and I've got this tree texture that I was doing, I'm going to switch it to a cover texture, and then I'm just going to render it as it is at the moment. And the rendering it as it is really just there because I want to see what it looks like with them just one per tile, right? And so there's the grass kind of cropping up there. So now what I want to do is I want to get this to be much smaller, right? I want to shrink it down. So it's probably going to be something more like this, right? It's not big. It's a tiny tuft of grass. And yeah, and off we go. So there's a tiny tuft of grass. That's probably a little too tiny. Maybe I got a little overzealous there. Let's try making those about twice as big. And we'll go from there. So there we go. And so now what I'd like to do is just spam a bunch of those into place, right? So when we're doing the push sprite here, what I want to do is have a way of pushing a bunch of those sprites on. And so I'll just do a loop for the moment. And again, I don't really know, this loop could be really slow, so we'll see in a second. We'll double check that it's not, and we'll go from there. So I'm going to push some number of these on, and I'm going to make a random displacement that is based on the radius. So we know that the radius is like ½ meter in either direction. So I just want to make a displacement. Here's the displacement. It's going to be 0.5f times two random numbers. And the thing about this, remember, is that these are themselves, they're not going to be signed, right? These are strictly going to be positive. So we need to make sure that they actually are signed. So actually, what we really want, instead of shrinking these down to 0.5, what I really want to do is offset them, right? So what I want to do is subtract 0.5 from them so that they're 0 to 1, 0 to 1. I want to subtract them so they're negative 0.5 to 0.5. And then the displacement I'll just add onto the ground P. And what I could do is I can actually make this into, like I can make this into 3 dimensions, right? By just saying, look, we don't want any Z displacement. I mean, I could put a little Z displacement in there, but generally speaking, I don't really think I want it particularly much, right? Oh, not sure why that's taken so long. So hopefully that just meant we rolled over and died. I'm not sure, though. It could mean that I did something horribly wrong. Let me just make sure that this is working well as we increase the numbers here. There we go. Okay, so now hopefully what happens is at some point when I'm getting up into some place where I break. Now the problem is we may just end up pushing too much stuff on the push buffer at some point, and we get like a problem with that has nothing to do with, like, we're just overwriting the buffer, right? Like, and I thought we had an assertion in there for that, but maybe it doesn't trigger, and this is a good time to try that because it should report to us in the case where it doesn't. All right, so here's this thing. Here we're operating, and we've crossed the line into badness. I'm going to find the exact point where we do, because I think that might make it a little bit easier for me to troubleshoot. But it looks like we don't properly assert, maybe, or maybe we just start throwing things out. I guess we just start throwing things out and we don't assert. Because it looks like the game still runs correctly. It just doesn't push any more stuff on there. So, yeah, is that really what happens? Let's find out. So all of these, they do check the entry. So shouldn't we be hitting this? Oh, but what about the current quads? Those make batches of quads. So those make batches of quads, which maybe don't actually have the checking. We checked the render buffer, we don't necessarily check the vertex buffer. Like, noticeably absent. Where did that check go? Did we really not have one there? That's kind of messed up that we didn't do that. I mean, we checked stuff pretty thoroughly here. That's pretty bad to not have that. I mean, no harm done, I suppose, but still, right? Because we explicitly have in the platform, well, I guess it's out in the renderer now, we explicitly have a thing that says how many there are for this exact reason, right? In the render commands, right here, this is there specifically for that. Right? So we should have been saying, you know, we should have been checking that all along. And I'm not sure why we weren't. Maybe I'm missing something, but I feel like that check should have been in there. Because that's messed up. So I don't know, maybe something else. Well, it didn't trigger, so maybe something else weird was happening there that I'm not understanding, right? But that's just kind of bizarre. So we didn't have a check for that. I'm not sure why. Maybe I'm missing something, and we actually do check it some other way. It looks like here we've got prevention in there. So this could have been, I guess, if we always call the current quads call. Get current quads. I'm glad we're doing this because this could be cleaned up quite a bit. So we always call get current quads and nerf it here. So I guess this is also, so this, we actually did protect ourselves against it. This assertion still should have been here. We were protected against it, but we didn't put an assertion, which we really want, because we don't really want the game in debug mode. And that shouldn't be not implemented. It's an invalid code path. In debug mode, we want to know as soon as we blow out the buffer size, right? We want someone to tell us that. So I'm glad we put that in there. That, you know, you never want to silently. I mean, it's good that we handle the failure case. So that was good, but it's in debug mode, you always want to fail loudly so that the person doesn't like just silently not know. You could imagine the bug being much more subtle than that, where some things just occasionally didn't render and they never got the assertion. They didn't realize that they were blowing out the size of some buffer that they needed, right? So you gotta have a loud failure in there. If you don't have a loud failure in there, then you can let more subtle bugs sneak in. Bugs like that where the whole screen, where it just stops drawing a huge section of the screen, well, those are easy, but you can't guarantee, right, that it's always going to be that straightforward. You know what I'm saying? So I think that's relatively important to keep in mind. So yeah, I think if we then just say, look, give us a lot more vertices, please, than we used to have. And we're just going to go ahead on and render to them. What's going on here? There's no way we're using that many vertices. Come on. Seriously? I mean, no, it's not possible. What did I do wrong? We do set the max vertex count somewhere, right? Yeah, it's right there. Is it a U16 or something? No. So tell me what the situation is here. Commands is undefined. Are we compiling in release mode? Yes, we are. Show me commands, please. Okay. If commands vertex count plus 4 times quad count is greater than max vertex count. Oh. It helps to put the invalid code path marker on the actual path that was invalid. Shockingly, I know you must be very surprised to hear that. But that actually is required. Okay. So this is good. It looks like it's getting a little bit dicier, potentially in terms of render speed, which is what I wanted. I'm not sure why we're not seeing here. I guess we haven't got, yeah, so you can see it's getting slower. So I should be able to just slow this down quite a bit here. And what I can do, there are some tricks that I can pull here I can do some additional work to make sure that we're not actually causing the problem ourselves in the push calls, right? So let's say I jack this up to something really bad, okay? And I make this thing go really slowly, okay? Not quite slowly enough. I mean like really slowly, like ultra slow. I mean, technically we could probably go slower than that, but you know, all right, that's fine, right? It's close enough. So when we are in this mode, right, and we're going really slowly, there's a couple problems. One is I don't actually know whether the slowness is from the renderer or from this code, right? So we don't know if like our push cube, push sprite calls are just too slow and they're actually causing the problem, right? But because we're just rendering from those buffers, that gives us an excellent opportunity to do something that allows us to see if that's true or not. So here's our global run rip, right? You can see us going down here. We create a render command buffer here, right? We push a bunch of stuff onto it. We render it. And then what you'll notice is every frame through, we generate a new one of these. Now, what we could do instead is actually not clear that buffer, right? Because actually, if you look at that buffer, all we really need to do is save the settings from the previous time through and just not update them. That's all we would need to do. And if we did that, then we could run without actually calling push scene, right? So this right here wouldn't actually need to happen. So what I could do is say, all right, let's see how fast we are if we don't re-push the geometry. So all I'm going to do is I'm actually going to let this whole thing happen. I think all I'm really going to do is take the vertex arrays stuff and not do it. Like, that's all I'm going to do. So basically, instead of push simple scene on here, I'm just not going to do that. The only problem is I need to update the camera transform. So that's a little harder. Trying to think of the easiest way to do this. So when I do push simple scene, like what I could do is maybe I could even do it with an if zero, right? Or an if around this, where if we've already done it once, we just save and restore that version. I think I can do that. So what I think I could do here is just say, yeah, like that max vertex count thing. Let's just save like, every time through here, I'm going to go ahead and get whatever the last vertex count actually is. And then I'm wondering if I can just do a thing where I read out the simple, well, yeah, I'm still just not sure how to do this right. I guess what I could do is just reach in and change the thing. I mean, I could just render the same scene without changing it. Maybe we'll just do that. So let's do this. And I could reach in and try to find that camera parameter too and change it. I suppose that would work too, to a certain extent. So here in the default render command stuff, right, all I'm going to do is just pull this out. So we'll initialize the render commands, and then what I'll do is I'll just do an if here to basically avoid doing this stuff in the case where we aren't actually going to update. So if updating, we do this, otherwise we don't. And we just use the render commands from last time. So that just means this is updating equals true. And if I just run the game as is, the test render as is, that should give me the same situation I had before. Slow, very kind of silly, ridiculously slow. And then when we actually go through to do the first time, after we update once, we just won't update ever again. So we only call that path once. And then from then on, we just render the actual same scene, right? And so then what we can see is we can find out how much of our time is spent in the actual render code as like the actual dispatching to OpenGL, as opposed to just the code that builds up the scene, hopefully, right? And then from there, we can have an opinion about the difference in speed between those two things, which is something that we want. And I could also reduce the number of frames we average across so that it doesn't take as long. But you can see right here, it looks like it's taking 90 milliseconds a frame, roughly. And that's without doing any of the push, without us doing anything. So that's strictly time spent in the render, either us pushing the information to OpenGL or like the card actually rendering it. So you can see there it's pretty clear like what's going on. So, around 90 milliseconds a frame. If I then just go ahead and let it update every time, this will give us a little bit of a clue as to whether our actual push buffer calls matter at all. And just to see whether there's much of a difference between those two things or not. I probably shouldn't rotate the camera just to compare apples to oranges, because this isn't a fair test, because the fill rate goes down right here when all these things are back facing. So we'll see. So it's not really a fair comparison, and I should just leave the camera where it is. So, it's a little slower, but not, so we still would want to optimize that push time. It's not great. So we still have problems with the computation, the push time. And so we can work on that, but it's clearly not the majority of the time. So we really need to fix that dispatch time, which is what we thought we would have to do. And so we should do it. This scene should not be hard to run. We should be able to get this running in 60 frames a second on a modern card like this one. So I'm pretty sure that mostly what we need here is a way to avoid doing those texture changes. Okay. So now that I've got that under control, I'm going to remove this temporarily here. Go back to what we were doing. I could put it back later, but I'm going to leave it this way. So I think that's all I really want to do for today on that test side of things. So I feel like what I could do is just leave the number of extra sprites pushed on here. Leave that down in like the low range, and then we'll crank it back up tomorrow when we want to start working on the texture stuff. So just leave it like this. And so now what I want to do is just go look at the API side of things a little bit more. So let's start with the basics. Here's the render loop, right? And here's the information that we want from OpenGL. And we can start documenting this a little bit here. We know that the window is passed as the LP parameter because that's what we're going to use. So I want to target. How about that? So here's just the steps that we're going through, right? I don't know about how we want to do the last counter. I'm guessing, I don't really think we want to quite do it that way. I think what I'd rather do is say, look, the last counter is going to be null. And then when we come through here and we get the end counter, I want to only do this update when we know that we have an actual valid frame. So what I'd like to do is say, and this probably doesn't need to be 300. Let's make it 120. 2 seconds. So what I'd like to do here is say, look, if last counter.quadPart is not equal to 0, then we'll do all this stuff. You know, otherwise we don't know how long the frame took, so we're just not going to do anything. Like, we're just going to render that first frame as like a do-over, right? And we're not going to time it. So, you know, that's, yeah. I mean, that's pretty much all we're talking about there. See, the frame variability is quite high, and I don't really know why. That would be a nice thing to look into at some point, too. Like, I don't know why it's such a... Like, that's a pretty wide range, right? And I don't know if that's because we're sort of, like, issuing two, and then we got to wait for the graphics card a little bit, and then issue another one, and I don't know why it's not leveling out as much. It could be because, again, of the VSync. So, you know, we could, in the Win32 OpenGL layer, we could look at the swap interval. And inside here, right, when we set this swap interval, what we could do there is provide a call for you to not do that. So what we could do is have in here a thing that says like internal void win32 set vsync, and have a vsync enabled where we say, look, if you want the vsync enabled, otherwise don't, right? And I guess I wouldn't quite do it that way. I'd probably do it this way, right? If vsync is supposed to be enabled, it's 1, otherwise it's 0, right? And then in here, we could, just for timing purposes, go ahead and turn that off. So we could say like set vsync false. And I could also say like OpenGL and so now it would allow tearing, and it will just run as fast as it can. It, in theory, won't wait for the vblank, but I mean, we don't really know whether it will or won't to a certain extent. It doesn't really look any different to me. I mean, it looks like it's still waiting for the vblank. Honestly, I don't see the tear. So I don't know. It could also be because if Nvidia forces us to do that, I don't know if they do. One of the things that happens is inside the Nvidia control panel, each individual 3D program, right, has overrides for it specifically. I don't know where that is, so here we go. Okay, so if you look here, you can see that there's like a bunch of settings, and in here it says like use the 3D application setting. In theory, that means that it is going to obey our call, I assume, right? But we don't know. And if I actually go to program settings, I can also see, like for my particular one, what would necessarily be set. We don't have an override, I don't think. Like, there shouldn't be an override for our stuff because we didn't create one. And so I don't think there's any reason why vertical sync would be forced off. So given that, I assume that this is as vertical syncy as it's going to get. And I guess, like I said, I don't know, but that's just seems to be the case. So assuming that is the case, we may just be forced to vsync because we're running through the compositor on Windows 10, and hey, we're in a window, right? Like if we actually put the full screen code in there, maybe we would see something else happen, but who knows, right? So yeah, so I don't know where that variability comes from. That will be a subject for future profiling to figure out where that's actually coming from, because we don't know. So anyway, here we go. Right? So we're just going to say, hey, start it up there. And there we go. So here's some simple explanations of what's going on here. So if someone reads this example, they can see. And so far, it looks fine to me, right? Like I don't see any weirdness happening here. This is what you would expect, right? And, you know, this is a pretty simple API, right? I say I want to initialize it. I say I want to set the vsync, right? And then in here I can look and say, well, okay, I need to allocate memory. And here's that information here, right? And these we can probably simplify a little bit in the future for a number of reasons. One is that, first of all, we can probably get rid of this notion of the textured vertex array, and we can probably convert like this all into one thing, I'm guessing. And then the other thing I think we could probably do is make it so that the push buffer, we may actually be able to just not have a push buffer at all, because since we know that we're just batches of quads based on the textures, we may just be able to just have those batches, right? Because we're not a general purpose renderer here. We're a sprite renderer, so we know we only render quads. So right, we don't really need a flexible push buffer. So to a certain extent, we may be able to just get rid of that entirely. It's just not relevant, and we can just pretty much ignore it, right? And just say, look, we've got batches of quads. The quads are completely homogeneous, and like you just go from there. And the only thing it needs to know is, hey, here's the pointer to the quads, and go to town. So if we just say that that's all it does, then it's a lot easier, right? And we probably don't really need a push buffer per se. You just have a giant list of quads segmented into two parts, ones that are all 512 by 512 textures and ones that aren't or something. So we can probably play with that a little bit and make it simpler. We certainly don't need this many pending texture operations. So this is where we're going to put all of those texture ops, and since we have to, you know, do that sort of texture, since those have to be queued up, we just want to let the person know that, hey, like however many textures per frame you want to download, you kind of need to have that queued up there. I still don't really know if that's the way we want the texture queue to work. It's a little confusing as to whether that's really appropriate or not, but it doesn't matter. Anyway, so here's the sort of scene stuff. And so this is the camera setup. I don't think so. We may want to pull out our stats here into something else so that those are not in line. Like you can see there's like a lot of this cruft here. Like this is cruft, this is cruft, that's cruft, and this is all cruft. So, you know, to a certain extent, I think we kind of want that to be like down here, you know? Because it just seems like maybe it's distracting. It doesn't tell you anything about the API. It's strictly for performance timing, you know? So I'm just thinking out loud here, like, what if we just pulled that out into a thing like frame stats? That would get rid of these variables to start with, right? It would get rid of this. It would get rid of this whole situation. And then you can just read through this. It's a little cleaner. It's mostly what you want. And then when you come through here, this back half, this part here, can actually be handled that way as well. So like all of this stuff, we could actually be a thing where you say like, okay, let's update this in some sensible way. Like, not sure how we really want to do that. You know what? Probably like this. So I think I want to do that. So basically in here, you know, we'll have a thing that would handle those stats. So this is like every frame. This is like and we'd have an init version. And so I think this is kind of nice because then it gets the stuff that you really don't need to learn the API. It's not really relevant. It gets it out of there, which I think is good because you're just trying to like focus the person who's trying to learn this attention on what actually matters in the API, you know? So here's the frame stats that we need to start out with. These are all already correct, so really this is the only one that actually gets initialized to an actual value, right? Because all the rest of these are just clear to 0, which is what we would want anyway. And in fact, we don't really have to clear this to 0. We could just make this be an init on 0 thing, but we need the perf frequency, so probably doesn't matter, right? Because this is going to have to be figured out here anyway. right? We're going to have to call this, so it seems fine at that point. And this doesn't really need to be global. So yeah, don't know why that was in the first place, but it was, I guess. So anyway, in here, when we do this, we can just make this pretty straightforward. That should do it. And so once we have that taken care of, we should be able to make this work off of the stats. So now, if I do stats last counter, it's that. So now what I can do is say, well, all right, we have to return seconds elapsed. We'll assume that the seconds elapsed is 0, so no time has elapsed at all. And then what we'll do is we always want to get the end counter, but we don't always want to compute the seconds elapsed value. So sometimes we want to, excuse me. And specifically what we want to do is we want to do it in this case, right? And then what we want to do down here is say that last counter equals end counter. So we want to get the end counter and update that. We only want to do the processing in the case where the last counter wasn't 0, because the first time through it's going to be bogus values. We want to avoid processing those bogus values. We can do the output debug string and all that fanciness every so often. This is off of stats, as is that. So all of this is fine. Oops. And that should do it, right? Yeah. Yeah. All right, so in order to get seconds elapsed, we need to do like that update frame stats thing, and we need to do our frame stats here. In terms of the frame stats themselves, we need to initialize them here. So we can do frame stats, and we can just do an init frame stats like that. And then I just need to make those be known. So here's the update frame stats bit. And here's the init frame stats bit. And there we go. Yeah, let's just do that. Okay. So we've pulled that out now, so it's not going to get in the way of somebody who's trying to use this. Let's just make sure it's still working okay. And we still actually we can see our seconds elapsed is obviously working because we are rotating at the right speed. And then we see the printout down there. So that just kind of, again, that just pulls it out and gets rid of something that they don't have or wouldn't want to look at, right? So yeah, like right here, we can put this up with the rest of the window stuff. So that will, just let people know we're doing that. I think everything else here is pretty self-explanatory with the comments that are in there now. So finally, what we want to do is say we're setting up the camera. So I don't want to put this. So just give them some idea of what's going on here. So this should be sort of making sense, hopefully, to people. I don't know. Maybe I should put this way. This is just like... So I think we're good there. Now we get down to this part here. And so there's a couple things. I think what I would like to do is we've got this T-camera shift here. We're doing an orbit. We've got one here that we're doing as well. And I'd like to do both of these. So I think what I might do is say, hey, every time we do a shift back by tau, that means we've done one loop around. I'm going to do like camera is orbiting equals false. And I'm going to do, or I should say like camera is panning maybe is false. And then I'm going to do like a if camera is panning here. And I'm going to make it so that we can do both of these movements to test the camera. And they'll just happen serially. So every time we do this, I'm going to do like camera is panning equals not camera is panning. So that like every time we wrap on tau, we will get that change. So we start out by like rotating around just to see what that looks like, you know. And then once we finish rotating around, then we will do a pan around. And it should alternate between those two. That way you don't have to flip a switch in the code to have the camera do something other than what it was already doing, right? And that seems pretty reasonable to me. Let's see here. Come along, Mr. Cody Poo. It's a nice speed for rotating the camera, but it's a little slow if you're waiting to see what happens when it finishes its entire orbit. So that seems fine. I guess the only thing that's a little annoying about that is that they're not coincident, but I don't really care about that. So this tests both of those things pretty well. And I'm fine with that. You can also see we get some problems where these grasses are too far forward. There's a bunch of weird stuff in there. So we're probably going to have to make sure that this this is a little too much. Like we need to make sure that they actually stay sort of semi-contained for lack of a better term, you know, so that they're sort of at least nominally inside the region, just for artifact avoiding purposes. So that's a little bit better, like to keep them like relatively confined to the space. That's all. Okay, so we've got this startup pretty well documented now, and then I'll say so that's pretty good. I think that's all pretty self-explanatory. And so now we get down to this stuff here. And I think this is where we could start to make a little bit of a difference here for the casual user. So if you look at what's going on here, there's just a little bit much, right? And some of these things here, like you could imagine us building this into some kind of a system that would handle things a little bit nicer for you. So if you look at what's actually going on, there's just a lot of business here. Let me spread all of these out. And just in terms of seeing what's going on. So like our begin render group and our depth peel and depth peel render group, like, well, I don't know that we really need the depth peel stuff in the end, because I think we can just auto depth peel everything and be fine with it. I think that the OpenGL, I think that like this stuff here is okay. If you just showed me this, I'd be fine with it. But the camera transform, like Z rotation, get standard camera percentage, aspect ratio fit, all of that stuff feels a little overwhelming for people who don't know like what all that was doing and why. It feels like maybe if you don't care, you wouldn't really want to have to do this stuff, right? And so it would be nice to kind of take a spin through and figure out how to maybe package that stuff up a little better. I'm also curious as to the draw region stuff. We've got window width and window height here, and we're making the draw region out of that. And then we're passing OpenGL render commands that. I want to make sure that all of this stuff is necessary and does what it thinks it's going to do. For begin and end render group, what are we using those things for exactly? Also, I'm curious. What is the pixel height stuff doing? Is that just there for the? Is that for the clip rect? For defining the clipping region? Is that what that's there for? I'm assuming that's what that's there for, but I don't really know. Okay, so it's there for two reasons. It's there for the clipping and it's for unprojection. So basically it's there because the clipping... yeah, so basically the clipping we only use at the moment for the debug system but the unproject we use for determining like where the camera can see. Those are both useful, so I feel like we want to continue doing that, right? That's pretty minimal. What does OpenGL render commands do with the window width and window height? Is that just because it needs to clear the whole region, or what? Yeah, so that's just because it needs to clear the whole region. And that's fine too. I say. So there's a couple things that I'm thinking about here. So I do think we may, in the renderer, have overcomplicated things a little bit. In that we didn't really bother, we didn't correctly... So when we specify things like clip recs, we're specifying those in pixel coordinates, but we don't need to specify them in pixel coordinates. They can be specified in just regular coordinates, like -1 to 1 or something, in screen space. And I do wonder if we're not just making life more complicated for everybody by doing them in the space that we're doing them. Because if you look at what happens in here, I suspect yeah, so I mean, we immediately take the pixels XY and we just turn it into screen space coordinates anyway. Right? Like that's what we do with it. So if you just didn't do that, if instead you just sent down -1 to 1 as your spread, then we wouldn't need to pass this in. And I'm guessing, and I could be wrong, yeah, I mean, nobody calls this in a non-debug sense except for inside the render itself. And the renderer itself, when it does like get camera rectangle at target, calls into here, and it passes the screen dim. So it's literally just passing its own thing to divide, right? It's dumb. So I feel like that screen dim really doesn't need to be there. It's not... So I feel like we've maybe made the renderer use pixel coordinates for no reason. And I mean, look, we're just doing it. It's really just doing it for no reason. So that's an API screw up. And the reason that's an API screw up is basically you can now see it's leaking out the pixel, the actual number of pixels on the screen are leaking out into code that wouldn't have had to know them. So code here that's just rendering a scene wouldn't ever have to know the number of pixels on the screen. And we're making them know it. And I don't care for it. That is non-good. So if I then look at the OpenGL renderer, where that actually interprets the clip rect. So you can see here, let me just make sure, yeah, there's only one place. So where this actually interprets the clip rect, so in this interpretation of the clip rect, instead of doing it as raw coordinates that we pass the GL scissor, which this is the only time we ever actually do that, instead of doing that, what we could do is just actually use the render height here and multiply the number that we get by the render height to get the clip rect. And that way, everything would always just work in terms of screen normalized coordinates. And that would be that. So I feel like that's what really should happen. I feel like that's an API cleanup we should do here. So looking at that, if I actually go to Handmade instead, so here I'm calling the actual game, right? So like here's an example of when clip rect. Oh, that reminds me of one more thing. Somebody asked why we were getting this error where placing the where having this over something makes the alpha, makes the depth peel compositing not work properly. And I realized I gave the wrong answer, actually. I said it was because we run out of depth peels. That's not why it is. These, if I remember correctly, are actually outside the depth peel pass. So I believe that what actually happens is, since these are rendered onto the top depth peel, which isn't strictly correct, I believe what happens is they just erroneously fill the alpha value of the depth peel with a new alpha value that's wrong. I think that's what's actually happening, right? We could fix this. And we probably should, right? We could fix this composite. It's only for debug mode, so it doesn't really matter, but it's worth noting, right? So what I was going to say is, here's something that uses the clip recs. And we also know something that uses the unproject, like the lighting, for example. So we should be able to see if we can do this removal. I don't think it would be that hard. The clip recs will break almost immediately if we do the removal, but I think we can get them back. So I think the only thing we really have to worry about here is the debug display code. So I'm just going to see what happens. How hard would it be to get rid of this, right? So if I come through here and I'm in the renderer and I just get rid of the fact that it even knows the screen dimensions at all, I want to see how much of a problem that places on me. So here's screen dim. It's gone, right? And what I do need to do to back that up is the clip rect right here in the render setup. That needs to be a floating point value. It can't be an I anymore. So it would need to be like a rect of that kind, right? So I'm just going to see what happens, and we'll go from there. So in here, when we get this clip rect out, here's the clip rect. And what I need to do is I need to create a rectangle 2i from it, basically. Like these need to become U32 values. So if what I'm saying is that this clip rect itself is like a -1-to-1 like specified clip rect, so it's in like screen normalized coordinates for whatever that actually means for the screen, then like right here, you know, we've already got stuff that does that, right? We have the render width and the render height and the 0 to render width, 0 to render height version of the viewport. So what I should, I believe in theory, be able to do is just say, okay, if I want to create min and max values out of this, then I should be able to say that the clip rect that I get, each of those coordinates can be transformed, like range transformed, into a U32, right? If I go to the math thing and I look at the lerp here, right? Lerp is sort of what I want to do, but it's 0-to-1, not -1-to-1, right? And so if I wanted to, I could make a lerp that actually worked as a negative one-to-one lerp. I could make one of those, and just that would be what I'd want. I don't know how useful this is, but I'm gonna say maybe we would do this. So S32 like binormal lerp. This is an incredibly special purpose function, but who knows? Maybe it's useful. So if we have a binormal t and we're going between two actual U32 or S32 values in this case, let's say, right? Then what I want to do is I want to convert this t to a 0 to 1 t. So this is like a t binormal. And to get a t normal, it's pretty straightforward. It's just half the range and then I offset it, right? Because if this is negative 1 to 1, this will make it negative 0.5 to 0.5, and then I offset it by 0.5, I get 0 to 1, which is exactly what I wanted. Then I can create a float result, like a floating point result, by doing the standard lerp exactly as I would have done it, right? So I can say, all right, just lerp between these two values as you would have done, and then finally I can create the result by doing the cast, like so. I don't know if we have one that can do that, do we? We'll find out. So then what I can do is say, let's get each of these rounded values together. So here's my lerp of these. And I probably want to look at these values, because if I get them wrong, and we step in the debugger, I want to be able to see them. So I'm just going to say, let's do a binormal lerp here to the render width, and a binormal to the render height, like so. So then I know my clip min x and my clip min y. And what I don't know is how big the rectangle is. I might just keep doing it this way, even though we could do the length directly. I'm not gonna. I'm just gonna leave it on a uniform path. I think that feels a little bit better to me. So now I can just do this and leave the computation exactly the same. Okay? So now I just say, all right, get the clip rect out, figure out what it actually is in screen coordinates, and then when you're done, pass that information to GL Scissor so it can have a little party, right? And that's all we need to do there. That's the end of that. So if I do that, now when we're actually setting that up in the renderer, what is this complaining about? V2 min-max. Okay, sorry. These are actually those. There we go. I think that's all good. All right. And so now what I need to do is I actually need to make sure that we're passing clip recs in the normalized screen space from now on, instead of in the space of the actual pixels of the screen. We stopped doing this. We know that was wrong. We fixed that, so that can just go away. Now we've got these sort of things that were using the screen dim before. I want those to be gone. So what we're going to do is the clip space x and y here. Again, that's supposed to just be a negative 1 to 1 value. So I think we can just use this directly. Like, I think we can now just say, look, forget that stuff. Don't worry about it. Let's do clip space xy as the input. So it's already in that format. So let's say that this is clip space xy. And then these are now responsible for just passing in that proper clip space value, right? So they are negative 1 to 1 now. Okay, so now when we call get screen point, you can see here we're actually doing this nonsense to produce a screen point. We're just going to say that whenever you call get screen point, you're actually going to get stuff back not in that space. Now, that's kind of obviously fine because the only people who call it are people who get the clip rect. And of course, the clip rect now goes the other way. Do I have any? I have a little. So this actually all just collapses down really well, as it turns out. So when we do get screen point, this is literally undoing the thing that we don't want it to do anyway, right? It's undoing something that we wanted done, I should say, right? We wanted in clip space. That is literally undoing clip space. So just forget it. Don't undo the clip space transform, right? So this is get clip space point here. And now when we get the clip space stuff here, just don't round it, right? Just make a rectangle min-max out of the min corner and the max corner. And everyone, hopefully, at that point, would be a happy puppy, right? I think, maybe, who knows? So when we get the clip rect out of these, we do those, we're going to get clip space back, and the clip space now is what we want. So that's a good thing. And I think then we can just move on from there, right? So we'll see how that goes going forwards. Let's keep going here. Now, inside begin render group, we don't need the pixel width and height. Those can go away. And then in here where we're setting up the clip rect, where we do rect min dim, now we know that this actually can just be a clip rect in this space, right? So for rect min dim, I don't know if we've got, let me just see here. I don't know where our rect min max calls are and stuff like that, or rect min dim. So if we look at where our rect min dim is here, it looks like we've only got an S32 version for that particular one. That's not really going to help us. So we want to do this. So what we'd like to do here is say, look, here's our... you know what? Let's do rect min max, because that's way clearer. Right? That's what we want. So that's good. Now when we have begin render group, we don't care about that. We don't care about this. And now I think we're just working on debug state, right? So now we just have to make sure that our clip rect stuff actually does something useful here. We don't need the width and height, right? So we just need that clip rect stuff to work. Let me go ahead and see where we set the rectangle 2i there. That's going to be one of these now. And we'll see if we need anything else. All right. So we've removed that part from the renderer. We don't know if this will work or not anymore. It might not. So you can see we're not getting any clickies there. So we've got some issues. Who knows what those issues are? We'll find out in a second. So looking at most of what we did, I think we're okay. Right? Like you can see like our regions are all right. If we actually go through playing the game, that all seems fine too. So it looks like the only thing we've really got wrong here is, I don't know if the clip recs are wrong, but maybe the clicking is wrong. So we need to look at the click part of things and just see, might be get screen point, or I'm sorry, I don't remember what that thing was called. There was like a get, clip space point, yeah. So these, I don't really remember how the clicking stuff worked here. Let's see in the debug system, how were we doing that stuff? Excuse me. Like, what are we even calling? We call unproject, right? So that's the problem there, is that we're calling unproject. And unproject is no longer, it needs this to be done, right? So what we can do is just provide one of those right here. So here's our inline v2 clip space from screen space. Right, this is it. And then that makes it so that you provide that. So here's your screen space XY. And then you can provide the screen dim yourself, right? So you can say U32 screen dim X, U32 screen dim Y. And then we can just say screen dim equals v2 screen dim X, screen dim Y. So this way you can do that. And really this is technically window space, I suppose, or pixel space, because it's not really screen. The screen is a thing. It's a whole monitor, right? It's not accounting for those things. So let's make that a little more explicit there, just so it's clear. And so we'll do pixel dim. Pixel dim, pixel dim, turn clip space. So then, as long as the person who wants to call unproject, we could say mouse pixel p equals this. Oh, sorry, I should say mouse clip p. So we can call clip space from pixel space there, and we just have to provide the width and height. With, I think, was getting passed in here, right? It's getting passed in here somewhere. I don't really know where. Well, if we called begin render group, oh, it would have been in the place where we're calling begin render group here. So in debug start, we have the width and the height. Do we save those? We do. So they're right here. So we can actually grab those out and pass those down, right? We could pass them as float. We're saving them as float, which, so I guess maybe we'll just, since this is the only person who even needs this, let's go ahead and actually just take them as float. I was taking them as, I was trying to be nice and take them as non-float, but forget that. They're float now, my friends. And so what we can do here is just go ahead and take those as float, let them call that, and now that should work, right? So now if I run it, hopefully we'll get clicking back online. There we go. And so now the only question is clipping working, and it is. So that's pretty great. I'm really happy about that. Now that means that we just don't have that extra annoyance, right? Because that was bugging me, and I like the fact that now you just don't, that's not part of the situation. Everything that happens in the render group happens inside the like that normalized coordinate understanding, which is just better. Because why leak pixels into something that doesn't need them, right? It just makes it more dependent. Yeah. This is, like I said, all comments are always inaccurate. All right. So that seems good to me, and I think we can end on that. So I really like getting that out of here. This is where that should go, not here. And And then this is fine because this is sort of telling us what we're going to do as far as camera fitting is concerned. So these sorts of things are fine. And I feel like that's where it belongs, right? Like camera setup stuff and this command stuff, that all I feel like belongs in the outside. This render group stuff shouldn't see it, you know? So I think we're getting better there. All right, I'm going to go to a Q&A here. Jordish, do you think you'll get back to 60 frames a second in the debug build, or at least a usable frame rate? I don't know, but I don't care, I guess, particularly much. Like the actual frame rate it runs in the debug build at the moment is actually fine with me. So, like that's fine. That's like totally usable. Like I don't mind that at all. Any other on-topic questions? Long Billion, do you want the renderer API to have a UI mode, basically a polished version of what the debug display is using, so no interaction with the lighting system, perhaps using screen space coordinates, or is that something that will always be for debug and 2D stuff will need to be handled by some other means? I haven't thought about it too much, but I don't really want there to be much UI at all in this game, if any. I would rather you're just playing. So to the extent that there's ever like a menu, I would want it to be like as simple as possible. So I don't think I would want to have anything even remotely as complicated as the debug system at the moment. So pretty much no. Like I think we would probably have just a very simple thing that's coded just for the one, like if we need a menu of some kind. Or something like that. But no, I don't think I would ever do that for this project. It just isn't, I don't really want there to be a lot of UI on the screen ever. Oh, for the other person who's using the render engine. No, because they already know how to do 2D. So I don't think they need me to do that. They can just go ahead and extend the render however they want for 2D stuff. I don't think there's really any issue. Right? It's just the 3D stuff they didn't want to have to know how to do. So if they end up using this renderer code, I'm not worried about their 2D stuff because I think they can just render that afterwards however they want. And they don't need me for that at all. I don't think. I mean, they've already shipped 2D games. So, like, I'm sure for UI, they don't need me to do anything. Oh, did I name that slightly wrongly? Yes, you're right. Should be in unoccupied. Oops. Okay, so any other on topics? Doesn't look like it. On Twitter, you said all user interface design is an adaptive compression problem. What did you mean by that? Well, it's, I mean, it's, I thought it was kind of self-explanatory. I just mean that you've got an encoder and a decoder, right? The encoder is the human, the decoder is the computer, and what you're trying to do is have the very minimal amount of interaction to get the result. So the human is trying to encode what they want to do. The computer is trying to decode that into something. So, you know, the best user interface is the one that has the least amount of stuff the human has to tell you, to tell the computer to do it. So what you're trying to design when you design a user interface is you're trying to design the most efficient human encoding process that the computer can still decode into the right thing, whatever that is, whether it's a text file full of code or a paint package decoding something into a drawing, you know, right? It's that's all it is. And I say it's an adaptive compression problem because it doesn't have to be static, right? The user can tell the computer things that it uses to adapt what it's doing to decode. Like, for example, if a user records a macro and then does the macro invocation, that's sort of like a dictionary lookup into a dictionary that got built on the fly, right? It's like an LZ compression, like macros are LZ, right? I feel like this is pretty self-explanatory, but maybe I'm wrong. Let's see. Going along with getting rid of unnecessary params, do the camera SOV aspect ratio near far clip plane need to be passed every frame, or are you going to move them out to a one-time setup call? Actually, all of those have to be passed every frame, except possibly the near and far clip planes. Because the camera FOV is animatable, and the aspect ratio changes every time the user resizes the window. Right? I mean, the aspect ratio doesn't, but the fit does, I should say. Right? This has to be done again. If that makes any sense. Furthermore, remember, the other person using this or whoever it is might want to support multiple aspect ratios, not just 16:9. So actually, this is completely animatable too, even the aspect ratio itself. So only the near and far clip planes are really ones that don't animate. But one of my comments had a grammatical error around 620. Was it okay? Thank you. I assume that's the one you're talking about. Nordic player. Hey, Casey, how can I start with C++? That might be one to ask the chat. Are you talking about like C or C++? That might be one better for the chat. I don't really have a lot of good advice on beginner stuff for C or C++ language learning because I learned it so long ago that I feel like there's probably got to be better resources now. I hope. But I don't know. I like having grammar checking. So we're looking good here. I'm liking this. I feel like maybe we clean up the camera stuff tomorrow. This part is looking pretty good. Clean up the camera stuff at the beginning of tomorrow. And then maybe this stuff we clean up, the push sprite, push cube stuff, right? And then that leaves us, for next weekend, just texture arrays. You know what I'm saying? Player, how do you manage your dependencies in a C++ project? Can you be more specific? What do you mean by manage your dependencies? I mean, I guess the manage part I can infer, but just define dependencies. Since there's a lot of different things that someone could mean by dependencies. So define specifically what you mean by dependencies, and I can definitely answer the question. Jim Zero, would you consider doing this sort of overhaul on any other parts of the code, like what you're doing with Thunder? Yeah, like I would definitely at some point want to do passes to improve the quality and design of things that we've organically sort of worked out. But we haven't really had yet a situation where we super need to do that and haven't done it. So at the moment, like, I don't really have plans to do that to anything in particular, but it may come up, right? So we may be like, yeah, we really want to really make sure this thing is good, so let's go ahead and break that into something pretty well nailed down. For the renderer, I think it's eminently worth it. This was an excuse to do this because someone might want to use it, so that's a good reason to do it now. But I wanted to do it anyway because we've gone through so many sort of things we've tried, because we sort of said, oh, let's do OpenGL, let's do lighting, that sort of stuff. Just in terms of visual quality of the game, I feel like it's worth taking a minute to say, hey, let's get this cleaned up. Let's get this into a state where, like, this is how the renderer works, and then we can go from there. So I think that's a good thing. Nordic player libraries. Okay. So generally speaking, in terms of using libraries in C++, I find that libraries, generally speaking, are not worth using, so I don't use any for the most part. And now I'll break that down. So I find libraries tend to have problems. They oftentimes don't work the way I want them to, or don't play well with my code. They like to do things like allocate memory when I don't tell them to, or create threads, or do things that I don't want. So there are very few libraries that I'm willing to use, but sometimes there are libraries that I want to use, and in the case where there are libraries that I want to use, here are some of the things that I do. Number one, I usually try to keep libraries isolated to pre-processing, and I don't put libraries into something that I ship. So for example, in a game, I do perhaps want to use the Ogg Vorbis audio compressor to compress audio. So what I will do is snap a version of the Ogg Vorbis DLLs, because DLLs don't have to be rebuilt and they don't have to be like maintained really. And then I will just get proc address on the DLLs, call them to compress the audio, and just use them that way. And then I just consider that like part of the build that I use is those DLLs, right? And I do that to keep their code out of my code so it doesn't bring in a bunch of stuff I don't want and make my build process more complex, right? So insofar as I can just snap a copy of the source to something, snap a build of the DLLs, put that aside and just use the DLLs from then on, that's what I'll do. In terms of using actual source in an actual runtime that I'm actually shipping to other people, I'm really selective about that. I'll only use code that I can make work with my stuff. So if it requires using the C runtime library, for example, I just won't use that. Like I would never use a library that required the C runtime library. If I can patch around the C runtime library by providing my own like malloc and free to it or something, and my own like file streaming, then I'll potentially use that library. And what I'll do there is just copy the source code into my project and build it in line with the project. I never, under any circumstances, use anything like external build management, project management, any of that stuff. Anything that might update things on its own is totally unacceptable. Like, I consider the build to be what the build is. I don't even remotely approve of like the left pad nonsense where like you automatically get updated packages from places or any of that stuff. That's like a totally unacceptable. There is no circumstance in which that should ever be done. I think it's like massive source of really bad situations. The number of things that are bad about that kind of development process are too innumerable to mention, but they have all at their base code that is used by other people and that other people are building products to depend on should be released very infrequently and tested very well. And that is the opposite of a sort of, you know, guns in the air, let's just update everything all the time and we don't even know how many products we're depending on and we're letting a package manager do it. It just, that just breeds like really unknowable bad like software situations where no one who even shipped this thing knows how it works, right? Or even what version of whatever software they're even using to ship it, right? So that stuff is just really bad, and that's because I tend to prioritize like reliability in a build and in software over the latest, newest, fast-moving, oh, we just got some new random thing in and we built it and let's just assume it works and off we go, right? Like, I'm not okay with that. I don't really believe you should treat your users like alpha testers all the time. It just doesn't seem like a good plan to me, and it's frustrating. I don't like being treated that way as a user. I preferred the days when developers had to do testing because, you know, they were going to ship you a disk and they couldn't ship you an update to the disk, right? I liked having that forced moment where somebody actually did some quality assurance. And so I'm just against that in principle. So that I can't really tell you. If you want to go that route, I'm against it. I never do it. How you would do it if you were somebody who wanted to, you'd have to ask somebody else, you know? All right, I'm gonna call it a day. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as it always is. Here's what I'll say. If you want to do some of your own API practice, you can always pre-order the game on handmadehero.org and try going ahead of me and seeing if you can do some API cleanup that anticipates the kind of cleanup that I might do. And then we can compare notes. So head over to handmadehero.org and check that out if you want to. We also have some other good stuff on there. There's a watch page you can use to check the schedule, and it also shows the live stream whenever the stream is live, so that's a pretty easy way to do it. It's also got the episode guide on there, so if you want to search episodes and play old episodes, it's really great. That's on there. Check it out. We also have the fund, the Handmade Fund, which you can contribute to if you want to support the people who are doing good work like that episode guide, or like the Handmade Network forums that some people use to discuss the series. All that stuff's on handmadehero.org. Check it out. We've also got, if you're interested in Molly Rocket in general and what we're doing during the day when we're not streaming Handmade Hero, you can always click on the little Handmade Hero head. It shows you our other projects in the works and also our personal blogs and our company blogs, so you can jump around through all those and see what's up. We also, of course, have a mailing list that you can subscribe to at any time. There's usually a little subscribe that you can put in there for our newsletter, which comes out very infrequently. It's only when we've actually got something interesting to announce, and it always comes with a nice little drawing from Anna as well, so there's a bonus to it, which is pretty pleasant. Anyway, that's all for today. I'll be back here for tomorrow when I'm going to try a little more cleanup of the API. And then I think we should be in good shape to kind of call it on API cleanup. Generally, what I then like to move on to is that performance. Just going in there and taking a look at the performance. And I think that's mostly about texture management, which we don't do, and we need to do it. So packing those things into a nice array, I think, is most of our problem. And then from there, we can take a look at anything more subtle that we might want to do. That's it for today. Hope to see you back here tomorrow. Until then, have fun programming. I'll see everyone on the internet. Take it easy, everybody.